last time we worked on the binomial theorem. So let's say I had 2x minus 3y to the 7th. How do I multiply that binomial by itself 7 times? So we could actually multiply it all out, which is going to take you forever. So we go to the triangle up on the wall. We go down to row 7, and we write down all the coefficients. 1, 7, 21, 35, and then 35, 21, 7, and 1. Okay. Now we go through and we write our A's and B's. And the A's start at 7 and they go all the way down to 0. So this would be A to the 7th, A to the 6th, A to the 5th, 4th, 3rd, squared, A to the 1st, and then that last one has no A's in it at all. And then the B's start with 0 and work their way up to 7. So B to the 0, B1, B squared, B to the 3rd, B to the 4th, B to the 5th, B to the 6th, and B to the 7th. All right, I'm missing one thing. Not what. There's one thing I've overlooked. Nope. There's a negative, right? So the B is negative, and we never want our B to be negative. So we say that A equals 2x and B equals 3y, and then what do we do with that negative? The first one's always positive, and then it just alternates negative, positive, negative, positive, negative, positive, negative, positive. So the first one's plus, minus, plus, minus, plus, minus, plus, minus. Does everybody understand that? Now I can plug in my x's and my y's. So 1 times 2x to the 7th. And always put your a in parentheses with the exponent on the outside. Minus 7 times 2x to the 6th times 3y. Does that make sense? Plus 21 times 2x to the 5th times 3y squared minus 35 times, oops, not a, times 2x to the 4th and 3y to the 3rd plus 35 times, oh, I did a again, 2x to the 3rd, 3y to the 4th, minus 21 times 2x squared times 3y to the 5th, plus 7 times 2x times 3y to the 6th, minus 3y to the 7th. Does everybody understand that? What is the relationship between the exponent of A and the exponent of B? You guys see that? How does the A exponent relate to the B exponent? They always add up to be, in this case, 7. So this exponent and this exponent add up to be 7. So 5 and 2 add to be 7. 4 and 3 add to be 7. 3 and 4 add to be 7. 2 and 5, 1 and 6, and 7. So your exponent of A plus your exponent of B will always tell you what row you're on as far as the triangle is concerned. Okay, now what do? I multiply all the numbers together and then I just stick the variables behind it. So the first one, I have 1 times 2 to the 7th. In my calculator, 1 times 2 to the 7th is 128, what? X to the 7th. Does Does everybody understand that? Now for the next one, I'm going to do 7 times 2 to the 6th times 3 to the 1st. And I ignored the negative. I would just leave the negative out of your calculator because you know it's going to be minus. So I type in 7 times 2 to the 6th times 3 to the 1st. So 1, 3, 4, 4. Then what? It's x to the 6th and y to the 1st. So x to the 6th, y. Does everybody understand that? Okay. For the next one, 21 times 2 to the 5th times 3 squared. 21 times 2 to the 5th times 3 squared. So plus 6048. And then what? X to the 5th, y squared. Everybody get that? Okay, for the next one, 35 times 2 to the 4th times 3 to the 3rd times 2 to the 4th times 3 to the 3rd is, and this one's a minus, 15120 x to the 4th, y to the 3rd. And then plus, over here, 35 times 2 to the 3rd times 3 to the 4th. 35 times 2 to the 3rd times 3 to the 4th. Is that going to fit? Let's see. We'll do a small 22680 x to the 3rd, y to the 4th. Okay, minus 21 times 2 squared times 3 to the 5th. And I get 20412 x squared y to the 5th plus 7 times 2 times 3 to the 6th. So 10206 x y to the 6th. And the last one is minus 3 to the 7th, which 2187 y to the 7th. All right, any questions about how to expand a binomial using the theorem? Okay, we're sort of going to do the same thing today, but sometimes they don't ask you for the whole equation. If I had 5x minus 2 raised to the 15th, that's going to take us some time, right? We're not going to do all of it. So instead of doing everything, it will ask, how about what is the term when n equals 4? So instead of doing all of them, just do it when n equals 4. Now you have to remember something about the triangle. The first number is not n equals 0. It's n equal, oops. The first number is not n equals 1. It's n equals 0. So when we go down to row, oh, we don't have row 15. So let's put up row 12. If we go down to row 12, which coefficient is n equals 4? So we go down to 12, and we start counting with 0. 0, 1, 2, 3, 4. 495. So 495 times a to the, count it over. So it would be, the first one would be a to the 12th. So 12, 9, or 12, 11, 10, 9, 8. A to the 8th, b to the, do we need to count the b's? If n equals 12 and a equals 8, then b would have to be 4. And actually, these numbers will always be the same. whichever term you're looking for, the exponent on b is going to be exactly the same number because you start counting with 0. B to the 0, B to the 1, 2, 3, 4. Okay. What about signs? Do I need to worry about positive and negative in this case? Yes, I have a subtraction. So if we look at the triangle, positive, negative, positive, negative, positive. 495 would get a plus. Does everybody understand why 495 is a plus? If you have a subtraction inside your binomial, the first term, the n equals 0 term, is positive. And then you just alternate. If it is negative, I would switch your a and b around. You'll get the same answer. But I don't think you'll ever see that. I don't think the 5x will ever be negative. If it is, just go ahead and switch them. If they're both negative, then I don't think that's going to happen. Yeah, it just the reason we're learning this is to learn something that will help in the future. But in the future, they're never both negative. It just doesn't happen. This is teaching us. It's like if you have a toolbox of all of your math skills, this just puts another wrench in the box so that when you get to higher math, you'll know how to use that tool. So right now it doesn't have any real world application, but all of these things that we're teaching you in algebra, they're just tools that can help you solve problems later. Well, so any mathematics job where you have a computer program that relies on calculus, yeah, you definitely would need to know the binomial theorem when you go, like if you're going to be an electrical engineer, certainly. So for this problem, I'm going to have positive 495 a, oops, not a is 5x to the 8th times 2 to the 4th. So I just type in 495 times 5 to the 8th times 2 to the 4th, and this is going to be a really big number. So 309375000 x to the 8th. And the problem will say, what is the coefficient in front of the term when n equals 5? So you have, the problem will give you a binomial. Here it is. It will give you an exponent, and it will tell you which term to look for. And then instead of doing all of them, you just find that one term, but the answer is just this number. That is the coefficient in front of the 5th term. Okay, so let's do one more. 4x minus 7 to the 11th, and I want to know when n equals 9. So I go to row 11. What is the number from the triangle when n equals 9? Did everybody get 55? So we go to row 11, and we start counting. We need to count up to 9, but you always start counting with 0. So we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and I get 55. Do I have to worry about positives or negatives in this case? Yes. So we look up there, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. So it's negative 55, A and B to what powers? Well, B is the easiest. B is going to be 9. And do I need to count A down? No. I know that I'm on row 11, and 9 and the other one have to add up to 11, so it's going to be 2. Or you could just count them. If you don't understand that, go ahead and count them on the triangle. So negative 55 times 4 squared times 7 to the 9th, or actually it's 4x squared, 7 to the 9th, and negative 55 times 4 squared times 7 to the 9th. This is going to be a huge number. Oops, not 79. 7 to the 9th. What does that mean? Negative 3.5 e to the 10th. So 3.5 e to the 10th means I need to move this 10 places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a really big number. And that won't happen in your book. Well, you could just write negative 3.5 e to the 10th. Okay, so take a look at 3.2. Okay, we stopped at what, 48? So you did 43 through 48, right? Okay, so now I want you to do same stuff. So 49 to 52. So 49 and 52, you're going to do the whole thing. So 49, 50, 51, and 52. Ignore that n equals 6. The book taught it in a different way, and it just didn't make as much sense, so I didn't teach it that way. So you're going to do 49 and 52, where you find the entire equation. And then you're going to do 55 to 69 odd. 55 to 61, you do the whole equation. And then 63 to 69, you only do one number. What's that? Okay, let me write it down. So you're going to do 49 to 52 all, and this is the whole equation. Okay? And then you're going to do 55 to 61 odd, and this is also whole equation. And then 60, well, let's make this odd. And then 63 to 69 odd, you're only doing a single term. Does that make sense? So in number 63, it says n equal 5. So you go to row 10, and you count over 0, 1, 2, 3, 4, 5, and you just focus on that one term. Okay? All right. Good luck.